Good morning to you all. Myself is Dr. SASILATha. I am handling the subject analog communication. First, in this class, let us discuss about what is communication, what are the different types of communication, and how do you generate signals, modulated signals, using different processes that we are going to discuss right now. First, let me discuss what is communication. Communication deals with the principle of transferring information from one place to another. So it involves both transmitter, receiver, and also there is a communication channel. You can look at the basic building blocks of communication system. There is an information source where the message will be generated. With the help of the transmitter, we can transmit the message. With the help of the receiver, we can receive the message. In between, there are channels. Channels may be either wired channel or wireless channel. In this class, we are going to discuss only about analog communication, where analog signals are transmitted and it is being communicated and it is being received. Basically, there are two different types of communication. One is analog communication, another one is digital communication. In analog communication, analog signals are transmitted, but in digital communication, digital signals are transmitted. The sources of information is either analog or digital. Analog signals are nothing but signals which varies with respect to time. So those signals are called analog signals, and these signals will be communicated through long distances with the help of analog communication. But in digital communication, digital signals like ones and zeros are being transmitted and it is being communicated and it is received. Now, for long distance communication, we need to go for modulation. You should understand the process of modulation. What is the necessity of doing modulation? Modulation is nothing but it is a process of changing the characteristics of the high frequency carrier in accordance with the modulating signal. You should understand what is modulating signal, what is message signal, what is modulated signal. Modulating signals are nothing but the message signals that may be either analog signal or digital signal. In analog communication, the signals to be modulated are analog signals, but in digital communication, the signals to be modulated are digital signals. So here, in modulation, we are going to make use of modulating signal, that is the message or the signal which is to be transmitted, and we need to use high frequency carrier. Carrier signals are used to carry the message or information since it is being transmitted over long distances. So during transmission, the signals may be affected by noise sources. While communicating from transmitter to receiver, it may undergo long distance communication. So the signals may be affected by noise sources. So to avoid the intrusion of noise sources, we are going to make use of high frequency carrier waves that is being used for modulation. You can see there is a modulator. The process is called modulation. You need to use baseband signal, which is nothing but the modulating signal or the message signal which is to be transmitted or it is to be modulated, and carrier signal is nothing but the high frequency signal. Both are mixed up inseparably inside the modulator. At the output of the modulator, you can have what is called modulated signal. So for this process, you need baseband signal or the signal which is being modulated, which is called as the modulating signal, and the high frequency carrier signal. Both are inseparably mixed up inside the modulator. Basically, it is a multiplier or mixer. You are able to get modulated signal. So here there are various types of modulation, analog modulation and digital modulation. In analog modulation, we have amplitude modulation, angle modulation. Under angle modulation, we have frequency modulation, phase modulation. And digital modulation again, PAM, PWM, PPM, PTM, and digital pulse modulation, ASK, FSK, PSK, BSK, QPSK, QAM, MSK, GMSK, and so on. Now let us try to understand what is analog modulation or what is amplitude modulation. In amplitude modulation, you can see the characteristics of the high frequency carrier that may be either amplitude or frequency or phase. So if you change the amplitude of the high frequency carrier wave in accordance with the modulating signal, that is called amplitude modulation. If you change the angle, which has both frequency and phase, then it comes under angle modulation. So these are under analog modulation, and the corresponding communication is called analog communication. But in digital modulation, digital techniques are being used. We have PAM, that is pulse amplitude modulation. Amplitude of the pulses are varied in accordance with the modulating signal, and here in PWM, pulse width modulation, width of the pulses are changed in accordance with the modulating signal, and here PPM, pulse position modulation, position of the signals are changed in accordance with the modulating signal, and in PTM, pulse time modulation or pulse duration modulation, this is being done. Similarly, in digital pulse modulation, we have ASK, which is corresponding to AM. ASK is amplitude shift keying. It is a technique which is quite similar to AM. And here in FSK, frequency shift keying, it is quite similar to FM. Then PSK we have phase shift keying, binary phase shift keying, quadrature phase shift keying, QAM, MSK. These things we will discuss one by one. Okay. Now coming to the amplitude modulation, you can look into this particular signal. You need modulating signal. This is the signal which is to be modulated. Then there is a carrier. It's a high frequency signal. You can compare this modulating signal and the carrier signal. Modulating signals are low frequency signals. They are the audio frequency signals. The range of signal varies from 20 Hz to 20 kHz. Okay. In the high frequency carrier, it is in terms of megahertz or in terms of gigahertz. Okay. So both these signals are combined inside the modulator or multiplier or mixer. You are able to get this modulated signal. Now you look at the signal, you can see inside this modulated signal, you can see the amplitude of the signals has changed with respect to the modulating signal. You look at the sidebands, which quite resembles the modulating signal. Similarly, here you look at the lower sideband, that also quite resembles the modulating signal. So, what do you understand from this modulated signal? Amplitude of the carrier is varied with respect to the modulating signal. So, this process is called amplitude modulation, which is being used in analog communication. Yes, sir. Now we can derive the expression for the modulated wave, that is amplitude modulated wave, using the equations of modulating signal and the carrier signal. Let us consider modulating signal Vm of t. Vm of t is nothing but modulating signal voltage, which varies with respect to time, is equal to capital Vm. This is the peak voltage of the modulating signal, cos omega mt. This is the frequency of the modulating signal. Understood? So Vm of t is equal to capital Vm cos omega mt. You can use either cosine wave or sine wave, whatever we want we can use. This is considered as the modulating signal. In the case of carrier, just have a look. Vc of t is the instantaneous voltage of the carrier signal is equal to capital Vc. Capital Vc is nothing but peak voltage of the carrier into cos omega ct. These two are given to the modulator, amplitude modulator. There is a process. Process is called amplitude modulation. Now at the output we have the modulated signal. Vam of t is nothing but instantaneous voltage of the AM wave. Instantaneous voltage of the AM wave. It is equal to, as I mentioned earlier, only the amplitude of the carrier varies. You look at the carrier signal, Vc. Instead of Vc, we have what is called Vc plus Vm cos omega nt. The change in amplitude is discussed here. You can look at this process and the modulated signal. Amplitude of the carrier changes. That varies with respect to modulating signal. It is not exactly equal to Vm. It varies. So, Vam of t is equal to Vc. You can see Vc up to this. Vc plus Vm cos omega nt. So, this particular voltage which varies with respect to time. So, at the output of the modulator, we have Vam of t is equal to Vc plus Vm cos omega mt. This is the change in voltage or change in amplitude into cos omega ct. The frequency of the carrier will not change. Okay. So, during amplitude modulation, frequency or phase of the carrier will not change. Only the amplitude of the carrier changes. Okay. So, modulating signal is equal to instantaneous voltage of the modulating signal. It is represented by Vm of t is equal to capital Vm cos omega mt. What is capital Vm? Peak voltage of the modulating signal. In the case of carrier signal, instantaneous voltage of the carrier signal is equal to peak voltage of the carrier signal cos omega ct. Omega ct is the angular frequency of the carrier. Omega mt is the angular frequency of the modulating signal. For finding the linear frequency, omega m is equal to 2 pi fm. Similarly, for omega c it is equal to 2 pi fc. Fm, fc are the linear frequency of the modulating signal and the linear frequency of the carrier. Now, the resultant amplitude modulated wave is equal to this VAM of t is equal to capital VC cos omega ct. You are taking this outside into 1 plus MA. MA is nothing but modulation index. You can include the term for modulation index is equal to Pm by Vc into cos omega mt. Now from this we can understand in the amplitude modulated wave we have three components. One is corresponding to carrier, another one is cos A cos B. In terms of sin A plus B and sin A minus B, we can write this as this is upper as well as lower segments also. So here in VAM of t is equal to Vc cos omega ct. This is nothing but the voltage of the carrier or carrier term plus the two components of upper and lower segments also will come in the picture. It is equal to omega c plus omega mt. Another one is omega c minus omega mt. So you can say that in the AM wave there are three components. One is carrier, another one is upper sideband, and third one is lower sideband. You can find out the modulation index of AM using this equation. MA is equal to V max minus V min divided by V max plus V min, or it is equal to Vc plus Vm, which is nothing but V max. V min is equal to Vc minus Vm. This can be derived from this particular amplitude modulated signal. So in this case, you can see V min is the minimum voltage of the carrier. V max is the maximum voltage of the carrier. Similarly, here also negative voltages minus V min and minus V max will come into the picture. From this, we can derive this expression MA is equal to V max minus V min divided by V max plus V min using the expression. Now, if you look at the frequency spectrum of AM wave, you can see there are three frequencies. One is Fc, this corresponding to the frequency of the carrier. And another one is Fc plus Fm is nothing but the frequency of the upper sideband. Fc minus Fm is the frequency of the lower sideband. Now, can you find out the bandwidth of the spectrum? That is upper sideband frequency minus lower sideband frequency, which is equal to Fc plus Fm max minus of Fc minus Fm max, or it is also equal to 2Fm. This is nothing but the bandwidth of the Fm wave. So bandwidth of Fm can be calculated from this equation also, which is Fc plus Fm minus of Fc minus Fm. This is the bandwidth. The bandwidth means width of the band. It is the difference between upper cutoff frequency as well as lower cutoff frequency. Okay. So this will be a carrier. So what do you understand from this AM? AM consists of three components. One is carrier frequency, another one is upper sideband frequency, third one is lower sideband frequency. So it consists of three different components. This can be derived from this final equation called VAM of t is equal to Vc cos omega ct into 1 plus Ma cos omega mt. This in turn can be written as Vc cos omega ct plus Ma into Vc into cos omega ct into cos omega mt. From this equation, cos A cos B can derive two upper as well as lower cutoff frequencies. Okay? Yes. Now, how will you find out the power which is distributed in AM wave? That we can see. Okay? So, in any electrical circuit, if power is dissipated inside the resistor, okay, it is actually represented using the RMS value. Now, the total power of the modulated wave will be is equal to sum of carrier power, sideband power. Okay, so PT is the total power in the AM wave is equal to carrier power is represented by PC, upper sideband power is represented by PUSB, and lower sideband power is represented by PLSB. In terms of the RMS value, you can represent this as PT is equal to V square carrier by R plus BLSB square by R plus BUSB square by R. Even you can represent this PC in terms of what is called the root mean square value, that is equal to PC is equal to VC square by 2R. You know, PC is the carrier power, PT is the total power, UUSB is the lowest segment power, and PUSB is the upper segment power, PLSB is the lowest segment power. Now, by calculating all these things, we are able to get this is PUSB, PLSB. Okay. Now, PT is equal to PC into 1 plus MA square by 2. So, this is the total power which is equal to, which can be represented in terms of the carrier power. So, PT is equal to PC into 1 plus MA square by 2. This is the total power in the AM wave. Now, you look at the spectrum, you can see carrier power is PC is equal to EC square by 2R. Then upper sideband power is M square PC by 4. Lower sideband power is M square PC by 4. Okay, this is the spectrum of AM wave. From this, you can understand that the power consumed by the AM wave is more. It includes both carrier power as well as the sideband powers. Now, instead of transmitting the entire signal over long distance, you can reduce the carrier power as well as the sideband power. What we want is only the message signal. So, that we will discuss in the next class. Thank you.